Hi everyone, it's Linnea Tucker. This is a video to get you ready for the comprehensive final in CPM3. So here's what I'm going to do. If you don't have a hard copy of this, I'm going to show you the questions. You can pause the video, work the problems, and I'll do that and go all the way through the comprehensive final. Then I will post the answer key. And then after that, I'll work every problem in order, okay? So my suggestion is you work the problems first, check the answer key. If you get them wrong, go back, see if you can rework them. And then if you're having problems, go into the video where I'm working the problems to get further instruction, okay? So here's 1 through 4. Pause the video. Here's 5 through 8. Pause the video. This is 6 through 9. That's the end of the first page. Pause the video. Oh, a little big. Let's go back up to the top. All right, let me get it where you can read it. Okay, you're going to need some graph paper. This is 10 and 11. Pause the video. (12 through 15). Pause the video. That's page 2. Here's page 3. This is number 16 through 20. So pause the video and work these. Here's 21 through 25. Pause the video and work these. And 26 wraps up this page. Pause the video. A little bit too big there. Okay, let's see. Make it a little bit bigger where you can see it. All right, here's 27, 28, 29, and 30. Pause the video. (30, 31, 32, and 33). This is the last of the practice problems, so pause the video. And this is the answer bank, and I can't remember if it's in order or if it's scrambled. So if it's scrambled, I want to go back and change it and put it in order. So, but it won't be if it's not in order, it won't be in order for the video. All right, so pause the video and check your answers. Alrighty, let's work number 1. Number 1 says simplify the expression. Now, when we simplify the expression, do you notice there's no equal signs in here? Do not throw in any equal signs. We are not solving for W. We can't because it's not an equation. We're just going to simplify the expression. So the first thing we're going to do is use distributive property on this first term, and we get 3W plus 6. Now we're distributing a negative here. It's like having a -1. So we're going to take -1 times +12. That's -12. We're going to take -1 times -W. A negative times a negative is positive, 1W. Okay, so we have distributed our negative. We've used distributive property. Now you're going to go in and combine like terms. I have 3W plus a W makes 4W. And then let's gather up our constants. A +6 minus 12 is -6. And we are done. It said simplify the expression, and our answer is an expression. Okay, number 2 says solve the equation. Now we do have an equal sign in there, and because we have an equal sign, we are solving for x. We will get a number as an answer. All right, so let's use distributive property on this side. Negative 6 times positive 2x gives us negative 12x. Let's take negative 6 times negative 5. We get positive 30. Now we bring down that equal sign. Here we're going to take a negative 3 times a positive 9. That's negative 27. Negative 3 times positive 4x is negative 12x. All right. We've got x's on the left side of the equal sign, and we have x's on the right-hand side. We want them on one side or the other. So I'm going to add 12x here, which means I have to do the same on the other side. What you do to one side of the equal sign, you have to do on the other. You notice that becomes a 0 pair, and that's also a 0 pair. And these drop out, and we're left with 30 equals negative 27. That's false. What does it mean if you wind up with a false statement? There is no solution. There is no value of x that you can pick and plug in here and here and make that equation true. Okay? No solution. Okay, number 3 says solve the equation for the indicated variable. We're solving 3x minus 6y equals negative 2, and we're solving for y. So I like to find the variable I'm looking for, the y, and get rid of everything else that doesn't have a y in it. So the first thing that we need to get rid of is 3x on this side. So let's subtract 3x from both sides. We are left with negative 6y equals negative 3x minus 2. Be careful. There's a lot of negative signs here. Don't drop a negative sign. Okay, so our y is right here. It's being multiplied by negative 6. We need to get rid of multiplication by negative 6. So let's divide everything by negative 6. Okay, negative 6 divided by negative 6 is positive 1. So it leaves us with y here. A negative divided by negative is positive. And this negative divided by this negative is positive. Okay, and we're not done because you've got to simplify these fractions. 3/6, top and bottom are both divisible by 3. 2/6, top and bottom are both divisible by 2. When you do that, you get y equals 1/2 x plus 1/3. Four says solve and graph the solution of the inequality, then write the answer in interval notation. Okay, I have negative 3x is greater than 12. I want to get x by itself. I have to undo multiplication by negative 3. So I'm going to divide both sides by negative 3. I'm dividing by a negative. Remember what you have to do when you multiply or divide by a negative? Do you remember? You must do what? Switch your sign. 12 divided by negative 3 is negative 4. And since we divided both sides by a negative, I have to switch the sign. Okay, so they want us also, I've solved it. They want us to graph. So here's my number line. Here is 0, negative 1, negative 2, negative 3, negative 4, negative 5. X is less than negative 4. It's not equal to, it's less than. So I'm going to use a bracket or a parenthesis. X is less than, meaning that all the numbers are smaller than negative 4. So our graph looks like that. And if you can get your graph correct, then the interval notation is easy. My smallest number is negative infinity. That will make this inequality true. My largest number is negative 4, but it doesn't include, so I need parentheses on both of those. Now you can check your answer. If you pick the number negative 5, it should make this true. If I put in -5 right here, I have -3 times -5, that's +15. Is +15 greater than or equal to 12? Yes. So I know that my arrow went in the right direction. Okay? Number 5, graph the inequality, then write the answer in interval notation. This is a compound inequality. It is already solved for x. What it says, if you want to break it up into two pieces, it says x is greater than or equal to 3, which if you flip that around, it says x is greater than or equal to 3, and at the same time, x is less than 8. If you want to look at it that way, you can. Okay, so here's 3, 4, 5, 6, 7, 8. On my number line, they want us to graph it. Okay, so my x is greater than or equal to 3. X is greater than or equal to 3. So I need the bracket with the arms going greater than, and at the same time my x is less than 8. So parenthesis here, and we're going to connect the two. All right? So if I pick a number like 5 and plug it in right here, is 5 greater than or equal to 3? Yes. And at the same time, is 5 less than 8? Yes. So I know I graphed it right. Now they want us to write our solution in interval notation. Well, if you've got it graphed right, interval notation is pretty easy. Bracket 3, your smallest number always comes first, comma 8, your largest number always comes second, parenthesis. Okay? So we graphed it and we wrote it in interval notation. I always go back and reread my instructions to make sure that I answered everything that was asked of me. All right, let's go look at number 6. Number 6 says solve and graph the solution of the inequality, then write the answer in interval notation. So I have x plus 4 is greater than and equal to 6x minus 16. Okay, I have x's on the right-hand side of the inequality, and I have an x on the left-hand side. I need them on one side or the other. So I think I'm going to subtract x here and subtract x here. These cancel each other out. Here I'm left with 4 is greater than or equal to 6x subtract x, 5x minus 16. Now I've got a constant on the left-hand side and a constant on the right. I want them all on the other side from where my variable's at. So let's add 16 to that side, which means I have to add 16 to this side. 4 plus 16 is 20. Greater than or equal to 5x. I want to get x by itself. Let's undo multiplication by 5. So I'm going to divide both sides by 5. And I get over here x, and you know this thing's pointing at the x, so it says less than or equal to 4. Now you've got to be careful. If you leave the x on the right-hand side of the inequality, you might put your arrow in the wrong direction. I always like to flip it around so that the x is on the right-hand side. This says x is less than or equal to, x is less than or equal to 4. Now, I don't think I'll graph it wrong. Okay, here's 4, here's 5, and 3 on my number line. X is less than or equal to 4. Here's 4, and it's going to be less than, so the little arms on the bracket go to the smaller numbers with my arrow going this direction. And I can check to make sure I did this right if I pick a number that would be a solution. If my number line continued out, I'd have 1 and I'd have 0, and 0 should be a solution if I graph this right. So put in 0 right here and 0 right here. 0 plus 4, the left side is 4, the right side is negative 16. Is 4 greater than or equal to negative 16? Yes, that's true, so I know I graphed it in the right direction. Okay, number 7. Number 7 says the perimeter of a rectangular billboard is 60 feet and it has a length 6 feet longer than its width. Find the dimensions of the billboard. Okay, I like to have a drawing. It says rectangular, and it says the perimeter is 60 feet. Perimeter is the distance all the way around, and it has a length that's 6 feet longer than its width. So if X represents the width, it says the length is 6 feet longer than the width. This is X plus 6. All right? It says find the dimensions of the billboard. Well, if I take X plus 6, which is the length, plus the width of X, this length over here is X plus 6. So let's add in another X plus 6. And this width here is X, so let's add in that X. That'll be the distance all the way around, equals 60. You've written your equation, now you can solve for X. Over on the left-hand side, let's combine like terms. I have 1, 2, 3, 4 X's. I have 4X plus 6 is 12, equals 60. We're solving for X, so let's get rid of 12. Let's subtract 12 from both sides. Subtract 12 and you get 4X equals, let's see, 60, 50, 48. I want to get X by itself. I have to undo multiplication by 4. So divide both sides by 4 and you get X equals 12. All right, now, does that answer the question? It says find the dimensions of the billboard. Well, if X equals 12 feet, then put in 12 right here. 12 plus 6 is 18. So it's 12 feet by 18 feet. And those are the dimensions of the rectangular billboard. Okay. Number 8. Find 3 consecutive integers whose sum is negative 114. Okay, let me just do a little review on consecutive integers. Consecutive means one right after the other. So 3, 4, and 5 are consecutive integers. Now, if I let the smallest number be X, I'll let the smallest integer be X. The next consecutive integer is what? Yeah, that's going to be X plus 1. And the third consecutive integer is what in terms of X? Yeah, that's X plus 2. All right? Now, I know the numbers are not 3, 4, and 5 because it says the sum is negative 114. So I'm going to add these together, and my answer is going to be negative 114. So on the left-hand side, let's combine like terms. How many X's do we have? Yeah, we have 3X, and then our constants, the 1 plus the 2 gives us a 3, equals negative 114. Okay? We're solving for X. Let's get rid of addition by 3. So we'll subtract 3 from both sides. Now, if you're not good with your integers, definitely consult with your calculator. What do you get when you take negative 114 and subtract 3? That's right, negative 117. I want to get to X. I need to undo multiplication by 3, so let's divide both sides by 3. Now, if you need to, consult your calculator. When I divide both sides by 3, I get X equals negative 39. Okay? So let's go back to this screen here. And let me just erase this and erase this. Okay, if my X is negative 39, if that's the smallest of the numbers, then I'm going to add 1 to it. So that's negative 38. And then I'm going to add 2 to it, to the negative 39. That's negative 37. Now, double check with your calculator. When you add those together, do you get negative 114? Consult with your calculator and see. Did you get up negative 114? I did. So our answers are negative 39, negative 30, well, that's ugly, negative 38, and negative 37. Okay? All right. Number 9 says find the slope of the line containing the points 8, 5 and 7, negative 3. If they want the slope and they just give you the points, you're going to use your slope formula. So first thing I want you to do is label your points. This is point 1, and this can be point 2, or the other way around. So if this is point 1, this is x1, y1. If this is point 2, this is x2, y2. Now I want you to set up this template, and I want you to put these parentheses in here. Remember, the formula is y2 minus y1 divided by x2 minus x1. I like to set this up in case I'm subtracting a negative. All right, so let's pop our numbers in now. My y2 is negative 3. My y1 is 5. x2 is 7. y2 is 8. Now, we just have to do the math. Here we have negative 3, subtract 5, that's negative 8. Here we have 7, subtract 8, that's negative 1. Now you need to simplify. Negative divided by negative is positive, and this is not simplified. Consult with your calculator. 8 divided by 1 gives you what? Yes, the answer is 8. That is not simplified. Number 10. Find the slope, the y-intercept, and the x-intercept of the line represented by the equation negative 3x minus 6y equals negative 18. Convert the equation to slope-intercept form, then graph the equation. Okay, I think what I'm going to do is find my intercepts first. What is always true of your x-intercept? Yes, y equals 0. So if I let y equal 0, that drops out of our equation because negative 6 times 0 is 0, and it goes away. I have negative 3x equals negative 18, so x equals what? Yeah, x equals 6. Let's do our y-intercept. What's always true of your y-intercept? X is 0. So if I put in 0 for x, negative 3 times 0 is 0, that drops out. I'm left with negative 6y equals negative 18. When you solve for y, you get what? Yeah, you get 3. We've got 2 points now that we can graph. I've got the point 6, 0 right here, and the point 0, 3 right there. Connect those with a line. Now, we still have to find the slope, and they want us to convert to slope-intercept form. So if we're going to convert to slope-intercept form, which says y equals mx plus b, where m is your slope and b is your y-intercept, and we know our y-intercept, we better get a b at 3. We are solving for y, which is this guy right here. So let's first get rid of the term that does not have a y in it. We have a negative 3x. To move that to the other side, we're going to add 3x. And we're going to add 3x over on this side. So I get negative 6y equals 3x minus 18. We want to get y by itself. We need to undo multiplication by negative 6. So let's divide everything by negative 6. Negative 6, and divide that by negative 6. All right, when we simplify, we get y equals, I have a positive divided by negative, so that's negative, and 3 over 6 reduces to 1/2 x. Negative 18 divided by negative 6 is positive 3. Here's our y-intercept, which is at 3, and that's what we got here. Our slope is what? Negative 1/2. Do not write the x in there. It's just the number, negative 1/2. We did graph a negative slope, so that's good. Now let's see, here we go down 1, 2, 3, down 3, and then right 1, 2, 3, 4, 5, 6. Rise over run is -3/6, which reduces to -1/2, and we are good. So we have got our x-intercept, our y-intercept, our slope, and we put our equation in slope-intercept form. Whew, that was a lot of work. Okay, let's move on to number 11. Number 11 says graph the equations, then give its slopes. On part A, I have x equals 6. Now, do you remember standard form for a linear equation says ax plus by equals c? That doesn't look like that. Slope-intercept form says y equals mx plus b. It doesn't look like that. Then point-slope form says y minus y1 equals m times the quantity x minus x1. It really doesn't look like any of those. But I know that one thing for sure, x equals 6. So I want you to go to the x-axis and put a point where x equals 6. Right there. And I want you to find another point on this graph where x equals 6. Well, x equals 6 right here. That's 6, 5. This is 6, 0. And down here I've got this point here. That's 6, -5. See? No matter what point I have, x equals 6. I have what kind of line here? Yeah, that's a vertical line. That's the vertical line. X equals 6. And vertical lines have what kind of slope? Yeah, you do have a rise, but there's no run. Say you've got a rise of 10, but a run of 0. Consult with your calculator. What does it say 10 divided by 0 is? Yeah, you get an error. So your slope for a vertical line is undefined. Remember Mr. Slope Guy, if you draw the face? Yeah, Mr. Slope Guy looks like this. Here's his eyebrow. That's a positive slope. He's squinting here, or winking at you. That's a negative slope. Here's a vertical line for his nose. See the U here? Vertical lines have an undefined slope. Here's his mouth. It's horizontal. It has a 0 slope. Okay, that's just a little memory aid. Okay, so x equals 6 is a vertical line. Let's look at the next one. We have y plus 7 equals 0. If we solve for y and subtract 7 from both sides, we get y equals -7. And once again, that doesn't really look like any of our forms. I mean, it kind of looks like slope-intercept form, but this piece is missing. Okay? On this one here, if you put your pen or pencil on a point where y equals -7, here's y equals -7 right here. And that's 0, 7. Put your point on another point where y equals 7. That is 5, 7, or that's negative. I'm sorry, that's 5, -7. That's what we're doing is negative. And right here, I've got the point 1, -7. And here, the thing they all have in common is y equals -7. We have got a horizontal line. And in this equation right here, it sort of looks like slope-intercept form if you make your slope equal to 0. Because 0 times any number is 0. That drops out, and y equals -7. What's the slope of this line? Y equals -7? Yeah, its slope equals 0. You can have a rise of any number, or you have a rise between 2 points of 0, but your run might be 5 or 10, and 0 divided by any number is 0. Okay, so all horizontal lines have a slope of 0, and all vertical lines have an undefined slope. All right, number 12. Decide if the given ordered pairs 1, 1 and 0, -5 are solutions of the linear inequality y equals -4x plus 5. Okay, well, here's my y. I'm putting a place to drop in numbers. Y equals -4 multiplied by, here's a place to drop in your x value, plus 5. Okay, so let's try out the first ordered pair. Let's put in a 1 here and a 1 here. I get 1 equals, what's -4 times +1? Yeah, that's -4 plus 5. -4 plus 5 is 1, and 1 equals 1. So this ordered pair is a yes. Is a yes. Let's try the next ordered pair. We're going to put in 0 for x and -5 for y, and be careful that you put those in the right places, because it's real easy to put them in the order that they come and put in a 0 right there and a -5 right there, and you've just messed up. Your y value here, you might want to label it so you don't mess up, that's -5. Let's put in a 0 right here. Is -5 equal to this side here? -4 times 0 is 0, and 0 plus 5 is +5. -5 does not equal +5, so that right there is a no. All right? Number 13, for the function f of x equals -4x minus 2, find the following. Okay, here's f of x equals -4 times your x minus 2. And in place of the x, they substituted in a -2. So let's take out the x and substitute in -2, which means what do they want you to put here? Yeah, they want you to put a -2 in there also. Now do the math. -4 times -2 is +8. Minus 2 gives you 6. So here, f of -2 equals 6. All right? Now for part B, let me erase all of this. Part B gets a little trickier. They say they want to know find the following. X for which f of x equals 0. Here's f of x. They want to know what value you're going to use for x to make f of x equal to 0. So substitute in 0 for f of x, and now solve for your x value. That's what they're wanting. Okay, first thing I want to do is get rid of this -2. I'm going to add 2 to both sides. So here I get 2 equals -4 times x. Let's undo multiplication by -4. I'm going to divide both sides by -4. Here I get x equals positive divided by negative is negative. And 2/4 are both numbers are divisible by 2. You must reduce your fraction and you get -1/2. Okay? And you can plug it in. If you put in -1/2 right here, will f of x equal 0? If I put in -1/2, negative times negative is positive. 4 times 1/2, or 1/2 of 4 is 2, and 2 subtract 2 is 0. So x equals -1/2. All right? Be careful with this one. You have to understand what it's asking for. Okay, 14. Simplify the following and with positive exponents only. If you have negative exponents anywhere in your answer, you are not simplified. We don't want negative exponents, we want positive exponents. Okay, so here, this is 9 times x to the -9 power. Do you remember the definition of a negative exponent? If I have x to the -n power, that simplifies to 1 over x to the +n power. So we are going to have to simplify that part right there. All right, let me get this out of the way. This is 9 times, let's use definition of negative exponent on that piece, 1 over x to the positive 9. And now we can multiply these two together, and I get 9 over x to the 9th power. And that's our answer. Okay? I'm going to do this one the long way, using definition of negative exponent, and then remind you of the shortcut. Okay? Here's my fraction bar. The numerator, x to the negative 10, is 1 over x to the positive 10 power. And in my denominator, y to the negative 4th is 1 over y to the positive 4 power. This fraction bar is a division symbol. And it says, take 1 over x to the 10 power and divide by 1 over y to the 4 power. Now to divide two fractions, you take the reciprocal of the second and multiply. So I have 1 over x to the 10th power multiplied by, let's flip this one over, y to the 4th over 1. And when you multiply these two together, multiply your numerators together, multiply your denominators together, and you get y to the 4th over x to the 10th. Now let me write where we started. We had x to the negative 10 over y to the negative 4. Take a look at this. What's the shortcut to get from this to our final answer? Do you remember the shortcut? If your exponent's negative in the numerator, it becomes positive in the denominator. If your exponent's negative in the denominator, it becomes positive in the numerator. You remember all of that? Yeah, that's a nice little review. Okay, so our final answer here is, let me back all this out. This here is our final answer. Y to the 4th over x to the 10th. All right, let me make some room for C. Get rid of all of that. All right, C. I had b to the 0 power. Any number raised to the 0 power is 1. So I can replace that with 1, and 1 times any number is that number. This whole piece right here goes invisible. Invisible number 1. All right? And I can separate what's left. I could say, well, that's 36 over 20 multiplied by a to the 8th over a to the 3rd multiplied by, well, let's go ahead and take that 1 right here. 1 over b to the 4th. Let's simplify each one of these pieces. 36 and 20, I know they're both divisible by 4. 36 divided by 4 is 9. 20 divided by 4 is 5. I have a to the 8th over a to the 3rd. Do you remember the shortcut there? If you don't, let me do this the long way, and I'll pause the video while I write this out. There we go. Okay, this is a to the 8th in expanded form. This is a to the 3rd in expanded form, and look what happens. Those 3 a's in the denominator cancel out 3 a's in the numerator, leaving you with a to the 5th. So the shortcut was, if you're dividing and bases are the same, take the top exponent and subtract the bottom exponent, and you get a to the 5th. You can put it over 1 if you'd like to. And then we still have our 1 over b to the 4th. There's nothing you can do with that. If you put it all together, you get 9 a to the 5th over 5 b to the 4th. And that's our answer. 9 a to the 5th over 5 b to the 4th. Okay? 15, rewrite the following using scientific notation. Okay, scientific notation says we have a factor times some power of 10. And if our power of 10, let's say it's 5, that creates a big number. If it was some factor a times 10 to the negative 5, that creates a small decimal sized number. So a positive exponent makes a large number, like this one over here. A negative exponent makes a small decimal, like this one over here. And the thing with scientific notation is this factor out front, that a has to be less than 10. And at the same time, it has to be greater than or equal to 1. So here my decimal point sits right here. I need to park it in this number so that I change this number into something that's between 1 and 10. So I'm going to move it to right here. So I know that my number is a small decimal, so my exponent is going to be negative. I know the number out front has to be 7.51. And the cool thing about powers of 10, you just have to count how far you move the decimal point. 1, 2, 3, 4. And most people make their mistake right there where they're counting, sliding the decimal. Okay, so there's A. All right, B is a large number, so I know that my exponent on my 10 has to be positive. Currently, the decimal point sits right there. I need to move it to right here. I want this to say 1.41 because 1.41 is between 1 and 10. Now for our exponent, we just count how far we move the decimal point. Be careful here. 1, 2, 3, 4, 5, 6, 7, 8. And I would go back and double check, before you write that in as your answer. Double check how far you moved it. Okay? 16 says rewrite the following using standard notation. Okay, A, 4.23 times 10 to the 5th power. The first thing I look at is the exponent. That's telling me I'm going to create a large number because the exponent's positive. So take 4.23 and you're going to move the decimal point which direction to make it a large number. Now we're going to move it to the right 5 places. So here we go. 1, 2, 3, 4, 5. Put zeros in those dips and we get 4, 2, 3, 0, 0, 0. That's the answer to A. All right, on B, I look at my exponent and I see it's negative. That means we're making a decimal out of this one. It's going to be a small number. So that 4.23, I need to move my decimal point which direction 5 places to make it small. Now we're going to go to the left. 1, 2, 3, 4, 5. Put zeros in here. And our answer should be, if you want to put that front 0 in, you can. 1, 2, 3, 4, 4, 2, 3. I move my decimal place 1, 2, 3, 4, 5 places. There's our answer. Okay, it says find the product and write the answer in standard form and scientific notation. I really think on the test they're just going to ask you to write it in probably standard form. I don't think they ask you for scientific notation, but we can do both. Okay, this is 3.38 multiplied by 10 to the negative 4th power multiplied by 4.18 multiplied by 10 to the 10th power. Okay, it's just one big multiplication problem. So grab your calculator and multiply those together. We have 3.38 multiplied by 4.18. I have 14.1284 times 10 to the, now if your bases are the same, what can you do with your exponents? Yeah, you add those together. 10 to the negative 4 plus 10 power is 10 to the what? Yeah, if you take negative Well, my video ran out on me, and I forgot what I was saying, because I can only videotape 15 minutes at a time. Okay, anyway, we multiplied these front two together and got that number. And 10 to the negative 4 times 10 to the 10th power is 10 to the 6th. If we're going to convert this to standard form, this exponent is positive, which means I'm going to make a big number, which means I'm going to move the decimal point 6 places which direction to make this a big number. Yeah, we have to move it to the right to make it a big number, and we're going to move it 6 places. So here we go. 1, 2, 3, 4, 5, 6. So in standard notation, our number is 141,284,000. Put in your commas. It's 14,128,400. That's standard notation. Now, I don't believe we've ever asked you to convert this kind of number to scientific notation. I've talked about it, and some of you are able to do that. If I make this 1 power of 10 smaller to create this number, this has got to get 1 power of 10 larger, times 10 to the 7th power. I'm dividing the front end by 10. That means I have to multiply the back end by 10. That's how you get 10 to the 7th power. So that's how you convert it to scientific notation. Number 18 says, evaluate the expression for the given value of x. I have 3x to the third for x equal negative 2. You know, this seems so easy, and a lot of people will get this one wrong. It's 3 times x to the third. Here's what I want you to do. I want you to take 3, make a place for you to drop in your number for x, and raise it to the third power. Now we're going to drop in negative 2. If you just run this through your calculator, definitely put in these parentheses or you're going to get the wrong answer. Okay? If you're going to do it by hand, it's 3 times negative 2 is being multiplied by itself 3 times. So it's negative 2 times negative 2 times negative 2. 3 times negative 2 is negative 6. Negative 6 times this negative 2 gives you positive 12. And positive 12 multiplied by that negative 2 gives you negative 24. The big mistake everybody makes here is they do this. 3 times negative 2 to the third power, and they run that through their calculator, and sometimes they get their sign wrong. If you take 3 times negative 2 and then raise it to the third power, without the parentheses, it's only going to take, your calculator only takes 2 to the third power, then multiplies by negative 1 and multiplies by 3. Okay? So you're okay there, but if it were an even number, you'd have a problem. So just be very careful. It seems so easy. You've got to watch out for those negatives. All right? All right, number 19. We are multiplying. First, we are multiplying the quantity 3x minus 5 times the quantity x plus 4. And you can use the box method or use FOIL. I'm going to use FOIL. I'm going to multiply my front two terms together. 3x times x is 3x squared. O in FOIL are your outside two terms. 3x times positive 4 is a positive 12x. The I stands for your inner two terms. Negative 5 times x is negative 5x. L is your last two terms. I'm taking negative 5 times positive 4. That's negative 20. Outsides and insides are always like terms, so you've got to combine them. We get 3x squared. 12x minus 5x is a positive 7x minus 20. Is that the answer that you got for part A? Okay, good. Let me erase this and we'll do part B. Part B says I'm taking the quantity of 4x minus 2 and I'm squaring it, which means I'm taking the quantity of 4x minus 2 and multiplying it by itself. Now you can use FOIL. Front two terms gives me 4x times 4x. That's 16x squared. My outside two terms is negative 2 times positive 4x. That's negative 8x. Inside two terms is negative 2 times positive 4x. That's negative 8x. My last two terms is negative 2 times negative 2. That's positive 4. You combine your like terms, your outsides and insides combine, and we get 16x squared minus 16x plus 4. Is that what you got? Okay, good. All right, on the last one, let me go ahead and erase all of this. On the last one, we have the quantity of x plus 4 multiplied by the quantity of x minus 4. So let's use FOIL on that. Front two terms gives me x squared. The outside two terms gives me negative 4x. Inside two terms is a positive 4x. My last two terms, positive 4 times negative 4 is negative 16. Combine like terms, those two cancel each other out, and I'm left with x squared minus 16. This answer is also known as a difference of two squares. Okay? Number 20, part A, I'm multiplying a binomial times a trinomial. I don't remember this ever showing up on a test, so it's probably an item that's not tested in this course, but since it's here, I'm going to go ahead and do it. You can use double distribution where you take this times this times this, which is actually, if you use it in a box, that's what we're doing. And then take this times this times this, which in a box, that's what we're doing. So if I multiply 3x times 2x squared, I get 6x to the third. If I take 3x times negative 5x, I get negative 15x squared. 3x times negative 6 is negative 18x. Now let's do the bottom row. We're going to take this negative 2 times each one of those terms, or positive 2. Positive 2 times positive 2x squared is a positive 4x squared. 2 times negative 5x is negative 10x. And 2 times negative 6 is negative 12. And then what you would do is you'd go in and combine your like terms. Those are like terms, and these are like terms. So our final answer is 6x to the third, 4x squared minus 15x squared, that gives you negative 11x squared, and then a negative 10x minus 18x, that gives you negative 28x minus 12. Yeah, I don't think you'll be tested on that, but if you were, that's easy enough to do. Let's do 20b. Number 20b, we've got this monomial times this monomial times this monomial. Let me do a little review with you. Any number raised to the 0 power is 1. Do you remember that? Any number, any quantity raised to the 0 power is 1. So that whole quantity of 6xyz, that whole thing is being raised to the 0 power, so this becomes 1. That whole thing right there becomes 1. And then I see inside the parentheses here, z to the 0 power, that's also 1. All right, so we can simplify right off the bat. This one's going to go invisible, and this one right here goes invisible, and we're left with this. So we're left with two monomials, each one of these terms being multiplied by each of the other terms. It's one big multiplication problem. Commutative property of multiplication states that it doesn't matter what order you multiply in, you still get the same answer. So I'm going to rearrange things and put like stuff next to one another. I put my coefficients next to one another, my x's, my y, and that one z. Okay, 1/2 times 8. Well, 1/2 of 8 is 4. When I take x to the second power and multiply by x, well, the exponent on this one's a 1. So if the bases are the same, what do you do with your exponents? Yeah, you add them. So that's x to the 3. Y to the what? When you take y to the 1 and multiply by y to the third, you get y to the fourth. And go ahead and bring down z to the fourth. And there you go. There's your answer. All right, 21 says factor. I have 4 terms. First thing I'm going to look to see is there a GCF? And there's not, because 21 is 7 times 3. They're both prime. That's not divisible by 7, so there's no GCF. So what we're going to do is we're going to factor by grouping. Okay, group the first two together. If you do this, you just made a mistake. You cannot subtract that negative sign from that 12x. All right, subtracting is the same as adding the opposite. So we could rewrite this as 16x to the third plus 28x squared. Subtracting is the same as adding the opposite. So adding a negative 12x minus 21. Now we can group. To factor, and you've got 4 terms, you've got to factor by grouping. So you group them together, and then you factor out a GCF out of each group. And our goal here is to wind up with common binomial factors. Okay? Between the 16 and the 28, I think my GCF is 4. And between x to the third and x squared, it's x squared. Okay, 4 times what gives you 16? Yeah, that's 4. X squared times what it gives you x to the third? It's got to be an x. 4 times what gives you the positive 28? Plus 7, and x squared times 1 gives you the x squared. All right. So 4x squared times 7 is 28x squared. All right. Since there's a positive inside of here, we want a positive also on this side, and I hope this says 4x plus 7. That's our goal. Well, in order for this to be positive, we're going to factor out a negative. So we're going to factor out a negative. What's common to both 12 and 21? Negative 3. Negative 3 multiplied by what gives you negative 12x? Yeah, that's going to be a 4x. Negative 3 times 4x is negative 12x. Negative 3 times what gives you negative 27? That's 7. Negative 3 times 7 is negative, did I say 27? 21. Negative 3 times 7 is negative 21. Now what I want you to notice is we have created common binomial factors. So when you factor that out of each one of these terms, take that out. I took that out and I took that out. What's left to go inside the second set of parentheses? I have 4x squared, and plus a negative is subtracting 3. Now, I think that's my answer, but double check with FOIL before you put a box around it. Front 2 terms gives me 16x to the third. Last 2 terms gives me negative 12x. Inside 2 terms gives me positive 28x squared. Last 2 terms gives me negative 21. So we are good. Now, how many of you got bit on the rear during this module on factoring because you didn't check with FOIL? Yeah, you know who you are. Yeah, please, when you factor, double check with FOIL. All right. All right, 22, we're going to factor these. I'm going to factor both of these 2 different ways. I'm going to factor it the book way, both with grouping and with guess and check, and then I'm going to do it with the box method. So this is going to take a little bit of time, but this should cover everybody on whichever method you chose to factor. Okay? You know, standard form for a quadratic expression is ax squared plus bx plus c. Now some of you could probably go ahead and just use guess and check to factor this, like this and like this, and you know, because that's a negative and that's a negative, this sign's got to be negative. That way when you multiply your last two terms together, you get that negative. Okay, so you just have to figure out what number goes here and what number goes here, so that when you multiply, you get negative 35, but when you add outsides and insides, you get negative 2. If you're doing AC method, you're going to take 1 times negative 35, which is negative 35, and you're going to put your B term, your negative 2, here. You're looking for two numbers that multiply to give you negative 35. When you add them together, you get negative 2. And I'm thinking of 5 times 7, that's 35. When you add them together, if this is negative, then you get your negative 2. And you don't have to use the box at this point. You don't have to factor by grouping, because now you know your 7 goes here and your 5 goes here. As long as your A is 1, you don't have to take it any farther than this. Now, definitely double check with FOIL. Front two terms gives you x squared. Outside two terms is negative 7x. Inside two terms is plus 5x. Last two terms gives you negative 35. When you combine insides and outsides, you get your negative 2x. So it's x squared minus 2x minus 35. We know that we have factored it properly. All right? Now, the next one's a little more complicated. Some people, I know, they like the guess and check, and you can go ahead and get that done. If you're a guess and checker, you know, you've got this and you've got this. This last term is negative, so you know you've got to have a plus and a minus in here. So you can go just guessing what goes in here and here and here and here. The rest of us, we're going to do ax squared plus bx plus c. And using the AC method, whether you're factoring by grouping or using the box, you have to do this. A times c goes here and your b goes here. Well, a times c is 5 times negative 7. That's negative 35. Our b is positive 2. And I think we've already seen that 7 times 5 is 35. This time we want a positive, so our negative term is going to be this one. Positive 7 times negative 5 is negative 35. When you add 7 and negative 5, you get positive 2. Okay? But if you put that in here, you're not done, because you've got this 5v squared in the front. You know a v goes there and a v goes there. If you are doing factoring by grouping, you're going to have 5v squared and the minus 7 over here. Let's make this negative 5v here and plus 7v here. Then you're going to group these together like this. Factor out a GCF between 5v squared and negative 5v. You're going to pull out a 5v, which leaves you with v minus what? 5v multiplied by what gives you negative 5v? Yeah, that's a 1. Here, between 7v and negative 7, we're going to pull out a GCF of 7, which leaves us with v minus 7 times what gives you negative 7? Yeah, that's a negative 1. Here's our common binomial factor of v minus 1. That leaves us, when you factor that out and factor that out, you're left with 5v plus 7. Check that with FOIL. It looks like it's 5v plus 7 and v minus 1. If you're using the box to factor, it looks like this. If you're using the box, you're going to put 5v squared here. You're going to put that negative 7 down here. And then we're going to take 7v and put here or here, it doesn't matter. Negative 5v here. Factor out your GCF in this row. That's 5v. The GCF in the bottom row is 7, and since this box is positive, that one's positive. The GCF in this column is B. The GCF in this column, the only GCF is 1, and since the adjacent box is negative, that's going to be negative. So here's our two factors, B minus 1 and 5B plus 7. Now before you go on, let's double check with FOIL. Front two terms gives us 5B squared. My last two terms gives me the negative 7. Outsides is negative 5B, insides is plus 7B. When you add those together, you get a positive 2B, and that double checks. So this is our answer. All right? (23), they want us to factor each one of these. Well, here I've got a binomial on A. I have x squared minus 81. It's a binomial. I see a difference, so I should be thinking of difference of two perfect squares. So, is the front term a perfect squared? What is being squared to give you x squared? Yeah, that's an x. The last term, do you have a number that's being squared to give you 81? Yep, that's 9. So we know the factoring pattern is this. They're the same, the x and the 9 and the x and the 9. But the sign in between is opposites. We call these two conjugates when the signs are different, but everything else is the same. You'll learn more about conjugates in CPM3. Double check with FOIL. Front two terms gives me the x squared. Outsides is negative 9x. Insides is positive 9x. They cancel out. Last two terms gives me the negative 81. Okay? Now compare that to this right here. I do have a binomial, and x squared is a perfect square and 49 is a perfect square, but we're adding them together. There is no factoring pattern for the sum of two squares. This one is prime. If you're adding two perfect squares together, you cannot factor it. All right? Let's factor the one in the middle. All right. For your guessing checkers, you're just going to do this. You know a z goes here and a z goes there. And since this is a plus and this is a plus, both of these are positive. You know, when you multiply your last two terms together, you need to get 1, and the only factors of 1 are 1 and 1. Now when you do outsides, you get a 1z. And when you do your insides, you get a 1z. And when you add those together, that's 2z. So when you check with FOIL, you get z squared plus 2z plus 1. There's nothing else you can use right here to multiply your last terms together and get 1. So b cannot be factored, and it is prime. Okay? Too many times you guys think you can't factor it and you want to write prime, but in fact you can, you just didn't try hard enough. So please be careful. Okay, on 24, they say solve the equation. Here we've got equations. That means we are solving for x. Now I know what people are going to want to do with a. They're going to want to use FOIL, and when they do, when you use FOIL, you're going to get 3x squared. That's a negative 3x and a 2x. You get negative x. Multiply that together, that's negative 2 equals 0. And now what do? You cannot solve this, you know, the conventional linear way because of that quadratic. To solve a quadratic for x, let me write this down so maybe this will burn into your brain. Solve a quadratic for x, and you know it's quadratic because you've got that x squared term. You're either going to graph it, and find the x-intercepts, because when we solve, that's what we're looking for, is the x-intercepts. You're going to graph it and look for the x-intercepts. And you can do that, but you know, if it's not if your x-intercepts aren't perfect whole numbers, it's going to be really hard to find. You can try to factor it using the factor method. You can factor your quadratic and use your zero product property, which I'll show you here in a minute. Zero product property or zero factor theorem. Or you can always use the quadratic equation. It will always work no matter what kind of, whether it'll factor or not. You can always use quadratic equation. The drawback to using the quadratic equation is there's a lot of places to make computation errors. Okay? So what we're going to do here is we are going to factor it. Okay? And when you factor this quadratic, guess what you get? You get 3x plus 2 and x minus 1. This one's already been factored for you. Don't use FOIL to multiply it back together because you're just kind of defeating your purpose. All right, now zero product property says if A times B equals 0, then A equals 0 or B equals 0. So this factor here, the 3x plus 2 must equal 0, or the other factor of x minus 1 must be 0. Now you can solve both of these linear equations. Here, subtract 2. You get 3x equals negative 2. Divide by 3, divide both sides by 3, and you get x equals negative 2/3. If you had graphed this, you wouldn't have gotten a whole number. You would not have been able to find this answer by graphing. So factoring or quadratic formula was the way to go. Okay, right here, let's add 1 to both sides. And x equals 1. Now if you plug x equals 1 back in here, that becomes 0. That means the whole product is 0. If you put in negative 2/3 right here, negative 2/3 multiplied by 3 is negative 2, and negative 2 plus 2 is 0, and 0 times this factor over here is 0. All right? So this one here has already been factored for you. Let's do the next one. I'm going to go ahead and erase all of this. All right, B, we're given a quadratic equation that hasn't already been factored for us. So we're going to have to factor that on our own. And didn't we just do this one? Yeah, if you look back, I think we've already factored this one. I think it was x minus 7 and x plus 5. Last two terms gives me negative 35. Inside this negative 7x, outside this plus 5x. Negative 7x plus 5x is negative 2x. All right, factored. Now using the zero factor theorem, x minus 7 has to equal 0, or x plus 5 has to equal 0. Here I'm going to subtract 5 on both sides. Here I'm going to add 7 on both sides. X equals 7 or negative 5. If you put negative 5 in, double check here, 25. This is going to give you a positive 10. 25 plus 10 is 35. Subtract 35 is 0. Put in a 7. 7 times 7 is 49. Then you're going to subtract 14. Gives you 35, and 35 subtract 35 is 0. Okay, so you've double checked your answer. And on this cumulative final, if you're taking the cum final, I sure hope you're double checking your answers. Yeah, we got to get you to pass. All right, number 25. Given f of x equals 12x squared minus 3x, for what values of x will f of x equal 0? We are trying to solve for x. Let's replace f of x right here with what? 0. 0 equals 12x squared minus 3x. It's quadratic, so let's see if we can factor it to solve. 0 equals between the 12 and the 3. I'm going to pull out a 3x. That's common. 3x times 4x gives me 12x squared. 3x times negative 1 gives me negative 3x. Using our zero factor theorem, 3x has to be 0, or 4x minus 1 has to equal 0. Here, if you divide both sides by 3, you get x equals 0. Here, let's add 1 to both sides. You get 4x equals 1. Divide both sides by 4. X equals 1/4. So the two values for x that are going to make this f of x equal to 0, make the whole thing equal to 0, is x equals 1/4 and x equals 0. If you put in a 0 here and a 0 here, you've got 0 minus 0, which is 0. If you put in 1/4 for x, 1/4 times 1/4 is 1/16. You've got 12/16 minus, if you put in 1/4 here, 3 times 1/4 is is 3/4. This is divisible by, the top and bottom are both divisible by 4. When you divide the top by 4, you get 3. When you divide the bottom by 3, top divisible by 4, you get 3. Bottom divisible by 4, you get 4. And 3/4 subtract 3/4 equals 0. So we have checked both answers. All right? Solve for x. All right, we do have an equation because there's an equal sign. We can solve for x and get a number. So let's use distributive property here. 4 times x is 4x. 4 times negative 5 is negative 20 equals 6x plus 24. This is not quadratic. This is linear. There's no x squared term here. So I want to gather up all my x's on one side and all my constants on the other. I'm going to subtract 4x from this side of the equal sign, and I'm going to subtract 4x on the other side of the equal sign. That's a 0 pair. I'm left with negative 20 equals 2x plus 24. I want to solve for x. This term has no x in it. Get rid of it. Let's subtract 24 from both sides. Here I get negative 44 equals 2x. Divide both sides by 2, and you get x equals negative 22. You can plug that back in right here, and make sure that you get an equal amount on either side. All right? 27 says, for what values of x is the function undefined? I like to restate that and say, what are your excluded values of x? You can use any x from negative infinity to positive infinity as long as you're not dividing by 0. You cannot divide by 0. So, look at your denominator. What value of x makes that denominator equal to 0? Because whatever you find, you're not allowed to use. Well, let's go ahead and set this equal to 0 and solve for x. I'm going to subtract 1 on both sides. I get 2x equals negative 1. Divide both sides by 2, and I get x equals negative 1/2. Now, if you put negative 1/2 in here, 2 times negative 1/2 is negative 1. Negative 1 plus 1 is 0, and you cannot divide by 0. So x cannot equal negative 1/2. All right, you can use all real numbers except for negative 1/2. That's the one value you can't use. All right, look at B. In the denominator, you know the denominator cannot be 0. So whatever value for x you put in here and square it, and then add 25 to it, if it equals 0, you can't use it. Well, if you put a positive number in here and square it, say 1, you're going to get 26 or 27 or 28. If you put in 0, 0 squared is 0, plus 25 is 25. What if you put in a negative number, say like negative 1? Well, negative 1 times negative 1 is positive 1. plus 25 is 26. If you put in -2, you're going to get positive 4 plus 25. No matter what number you put in for x, when you square it, it's going to turn out to be a positive, and a positive plus a positive is always positive. There's no way to get a value. The only way your denominator could be 0 is if this was -25, and there's no way to multiply two identical numbers together and get a negative answer. So here there are no values that you cannot use. You can use all real numbers. There's no value of x that makes this function undefined. Okay? You can use all real numbers. We have no excluded values. All right, we're going to solve a proportion. And let me give you a proportion. 1/2 is the same as 3/6. And if in fact it's proportional, then your cross products are equal. 2 times 3 is 6, and 1 times 6 is 6. So we're going to use the fact that we know in a proportion cross products are equal to solve this. We're going to take 3 times the denominator down here, 3 times the 2x plus 1. We know that cross product has to be the same as 8 times this quantity here. 8 times the quantity of x plus 4. Now use your distributive property, and you'll have a linear equation that you can solve. Distributive property, I get 6x plus 3 equals 8x plus 32. I got 6x on this side and 8x here. I'm going to subtract 6x from both sides. 3 equals 8x subtract 6x is 2x plus 32. I'm going to subtract 32 from both sides. I get 29 equals 2x. Negative 29 equals 2x. Divide both sides by 2, and I get x equals negative 29/2. You could, if you wanted to, convert that to a decimal, plug it back in for x here and here, do the math and make sure you get 3/8, or that your cross products are equal. Okay? 29 says simplify. All right. I think what we're going to have to do is factor this out and see what happens. I notice in the numerator that I have a GCF between x to the third and 7x squared, and my GCF is x squared. Factor that out. X squared times what gives you x to the third? That's just an x. Plus 7, or x squared times what gives you 7x squared? Yeah, that's got to be a 7. Okay, factor the denominator. I know an x goes here and an x goes here. The only way to multiply your last two terms and get a negative 14, one has to be a plus and one has to be a minus. There's the two factors of 14 that come to mind is 7 and 2. When you do outside inside, you have to add up to positive 5. What if you put the 7 there and the 2 there? Front two terms gives you x squared. Last two terms is negative 14. Insides is 7x. Outsides is minus 2x. 7x minus 2x is your 5x. All right? Still, here I am double checking my factoring with FOIL. I always do it. Now I see that this quantity of x plus 7 cancels out with this quantity of x plus 7, and it leaves me with an answer of x squared over x minus 2. Part B says, for what values of x is the function undefined? You can't look at the answer. You need to go back to factored form right here. Your denominator can't be 0. So x plus 7 cannot equal 0, and x minus 2 cannot equal 0. Subtract 7 here, add 2 here and here. x equals -7, x equals +2. If you plug in -7 here, you get 0, making the whole denominator 0. If you take an x of 2 and put it in right here, you get 2 minus 2, which is 0, making the whole denominator 0. So here are the values of x that you cannot use because it makes the whole function undefined. All right? Yeah, you can't plug it in just here because you'd only get this one answer. You've got to go back to factored form. Number 30, we're going to multiply these two together. We're going to multiply tops times tops and bottoms times bottoms. That's 8x to the third times x to the fifth over 2 times 4 times x to the ninth. That simplifies to 8x to the what power? The bases are the same. You add your exponents. Here, 2 times 4 is 8. We've got x to the ninth here. These 8's cancel each other out. Now remember, if your bases are the same, you take the top exponent and subtract the bottom. If you do that, you get x to the 8 minus 9, which is x to the -1. But that's not simplified. You cannot have a negative exponent. You've got to go back to your definition of negative exponent, and our final answer is 1 over x to the +1 power. 8 of these x's being multiplied together in the numerator cancels out with 8 of them in the denominator, just leaving 1 in the denominator. All right? Number 30, we're going to divide this fraction by this fraction. To divide fractions, you flip the second one and you multiply. So here's my first fraction. Put parentheses around all your expressions. Okay? And I'm going to multiply by the reciprocal of this one. So x squared, the denominator here becomes the numerator here. And the numerator up here becomes the denominator here. Now, let's factor the numerator and the denominator. X plus 2. 7 minus x. Okay. Here, I know it's going to be an x and an x. 14. I'm going to try 2 and 7. And when I combine insides and outsides, I should get -9x. Since that's a positive and that's a negative, both of these are going to be negative. Double check with FOIL. Yep, -7x plus -2x is -9x. My last two terms gives me the +14. Down here, I know I've got an x here and an x here. That's positive and that's negative. Two numbers that multiply to 6 but add up to -5. It's -2 and -3. Double check that. Okay, that's -5x and 6. All right, we are factored. Now we can start crossing stuff out. That crosses out with that. These don't. These are opposites. I have a positive x here and a negative x here, a +7 here and a -7 here. If you factor out a -1, that makes this a -7 and a positive x. Okay? Now I've got a positive x here, a positive x here, -7, -7. These cancel each other out. This positive numerator divided by a negative denominator gives me a negative fraction, x plus 2 over x minus 3. All right, let's do 32. It says convert 176 pounds to kilograms. Round your answer to the nearest tenth if necessary. Underline that, because everyone forgets how to round. And then they give you your conversion factor. Okay? I'm going to do a little picket fence thing. 176 pounds. That's what I'm starting off with. I want pounds to cancel out, so I'm going to put pounds down here. I know there's 16 ounces in a pound. There's 16 ounces in 1 pound. All right, so these have canceled each other out. My units of pounds have canceled. Now I'm going to use my conversion factor. Okay, so this will convert to ounces. Now let's put our ounces down here. Grams is going to go up here. In 1 gram, there's 0.035 ounces. Okay, so now my ounces cancel each other out. And where do they want us to go to? Oh, kilograms. Okay, so if I have grams, I want grams to cancel out down here. Grams in the numerator cancels out with grams in the denominator. There are 1,000 grams in 1 kilogram. And since all of the units canceled out except for kilograms in the numerator, where we want it, that shows us what we multiply by and what we divide by, and our units will be kilograms. So we're going to take 176, multiply by 16. In the denominator, we're going to take 0.035 right here and multiply by 1,000. And then take the numerator and divide by the denominator. So go grab your calculator. I got mine here. 176 multiplied by 16 gives me 2816. In the denominator, take your 0.035 and multiply by 1,000. That moves your decimal point 3 places to the right, and you should get 35. So now take your 2816, divide by 35, and you should get something like 80.457 kilograms. But now they want you to round to the tenths place, which is right there. So the answer is 80.5 kilograms. Is that what you got? Okay, good. All right, I think this is the last problem. It says a doctor orders 250 milligrams of a drug for a patient. You have on hand tablets of the drug with a dosage strength of 0.5 gram per tablet. How many tablets should the patient receive? And note, 1 gram is 1,000 milligrams. Okay, so I've got 250, he orders 250 milligrams. But my tablets are in grams, so let's take milligrams. I know I want milligrams down here. Use that conversion factor. There's 1,000 milligrams in 1 gram. And I know I did this right because my units in the numerator cancel out with the denominator. Okay, so that leaves me with grams. And I know my dosage strength per tablet is 0.5 gram per tablet. Well, I've got grams in the numerator. So let's put the 0.5 grams in the denominator, and that's per 1 tablet. Grams in the numerator cancels out with the grams in the denominator. And I'm left with tablets, and that's what I want. How many tablets does the patient receive? So this is telling me I'm going to take 250 times 1 times 1, which is 250. And in the denominator, I have 1,000 multiplied by 0.5. So that's 250. Let's see, if you take 0.5 and multiply by 1,000, it takes your decimal point and moves it 3 places to the right to make it bigger. 1, 2, 3. 500. Isn't 250 half of 500? Yeah. If you take 250 and divide by 500, you get 0.5 tablets. So they're only going to get 1/2 of a tablet. Okay? All right. I think that's all I have for the review. Now, if you got stuck on any of these and you really didn't understand my explanation, please come ask one of the professors or ask one of the tutors in the math lab, because sometimes hearing it from somebody else using just slightly different words might click for you where, what I said didn't. So please mark down the ones you didn't understand, and we'll go over them again prior to you taking the cumulative final. Good luck.